So, but these are the only ones, the noble gases are the only ones that are so stable that they don't need to combine. So look at the Lewis dot structures. They're exactly the same for everything. Ta-da! See? They're exactly the same, except for helium, but the inside of helium is exactly the same as everything else. Just go with it. Anyway, so let's look at the periodic table, elements 1 to 20, but with the Lewis dot structure. Yes! Anyway, so hydrogen, lithium, sodium, potassium. There is some kind of trend there. I don't know what it is. No. Beryllium, magnesium, and calcium. There's some sort of trend there too. Boron and aluminum. Yeah, there's another trend. Carbon, silicon. Whoa, another trend. Ooh, this one's a fancy trend. Ooh, this one too. This one's also pretty cool. And this one's the last fancy trend. Now, can you figure it out? There, the rows are exactly the same. Here, look, there, 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 and pretty much everything. See? Look at the box things. Ta-da! That's why they're almost always the same. And you can kind of think of it as a building where its top person is almost exactly the same as the bottom person. And that's why they have similar properties. Now, if you're not a happy atom and you want to get happy, you have to join up with other atoms. Like two hydrogen atoms, if they combine, like this, they have 2 electrons in the innermost shell, and that's how many as you can hold, and that's how you become sparkly. Just kidding. That's how you become happy. Now this pair is a happy atom, each one. And this is the Lewis dot structure for this configuration. HH, H2, or hydrogen gas. Okay, so that's it for happy atom. But there is this thing called electron configurations, and to figure out let's get an example of an electron configuration. Weird one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. This is the electron configuration of iron. Okay, so let's figure out how to do an electron configuration. So, an electron configuration is an electron configuration. Well, let's make some categories first. So this would be the S block. This is the D block. This is the P block. And this is the F block. Of course, there's an F block right here too. Ooh, so jello-y. Why? It's so weird. Ignore me. Anyway, let's dim them a little so we can see the elements. Okay, so for hydrogen, let's get an example of hydrogen. So hydrogens. So how to get electron configuration? First number is the group, the period number, and then it's the box it's in, and then it's the number in that period. So let me explain. So for example, hydrogen would be 1 because that's the period it's in. S because that's the box it's in, and 1 as a superscript because in this period it's number 1. Now let's try beryllium. Beryllium, you start by just starting with hydrogen, so you start with 1s1 again, 1s2 actually because you're including helium, 1s2, hello. Okay, there you go. And then 2, because that's the period it's in. 2s, because that's the group it's in. And then 2, because that's the number it's in. Like that. And that's the configuration for beryllium. Now let's go back to iron. Iron is 1s 1s2 2s2, and then go into the p block. 2p, because that's the group it's in, and then 6, and then 3s2, because that's the next row. 3p6, 4s2, and then last part. And D is kind of weird because, well, it decreases by 1, the period number. 3d6, not 4d6. Okay, let's try a hard one. For example, F in the F block. What about plutonium? One thing you have to know about the F block is that if you have an element in the F block, it goes down, the period goes down by 2, not 1. Okay, anyway, so let's try plutonium, element 94. Okay, so it would be plutonium, Pu, 1s2, 2s2, 4f15, 5d10, 7s2, 5f5. That is the configuration for plutonium. By the way, it's not 4s15. By the way, it's not 4s15. It's 4f15. And there's a difference there. Anyway, so here's another chart for you. So you can just copy this if you want. Also, here's another way. So you start at 1s, and then you do 2s, then 2p, 3s, then 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4, 5d, 6p, 7s, 5f, 6d, 7p. Now this is how to write out electron configurations. So what did we do? All these things. Okay, so today you learned how to determine what atom is where on the periodic table, how to plot an electron configuration and write it down, why electrons are the actual funnest part, what and why Lewis structures are, what happy atoms are, and why these pieces of info are getting smaller. By the way, I didn't answer that other one, but the last one, but the answer to that is I have no idea. See you on howtodoaliens.com and see you next time, because that's the end of the video. Bye! Bye 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 bye.